A plane flew from Thunder Bay, Ontario to Halifax, Nova Scotia, a distance of 3,000 kilometers into a headwind. With a tailwind, the plane flew 100 kilometers an hour faster on the return trip. The total flying time was 17 and a half hours. What was the flying speed from Thunder Bay to Halifax? So this is a chart question. Make a chart. The chart takes the place of your let statements. So we have from Thunder Bay to Halifax, Halifax to Thunder Bay. And we're going to be using the relationship. We're going to be using the relationship that distance is equal to speed times time. We're told that on both legs of the trip, the distance is 3,000 kilometers. The unknown value that we're trying to find in this question is the speed from Thunder Bay to Halifax. That will be our x. What will be our time? Well, what we're going to do for that is, if, for example, you flew 1,000 kilometers not in, but rather at 400 kilometers an hour. How would you find out how much time that would take?
You divide your distance by your speed.
You divide the distance by the speed, and you get 2.5 hours. Now that was just a little bit of a side note to show you. In this chart, we don't know the speed, other than the speed is x. So the time is 3,000 divided by x. We do know that the plane flew 100 kilometers an hour faster on the return trip. We don't know what the speed was going there, other than to say it's x. So the speed coming back is x plus 100.
Oh, okay.
And we also know that the total flying time is 17 and a half hours. So we don't know what the time was getting there, but we know that the time getting back will be the total amount of time minus the time it took to get there, which is 3,000 over x. And now we have the makings of a quadratic equation using the fact that distance is equal to speed times time. We are going to use this stuff down here. The distance is 3,000. The speed is what? X plus 100. The time is what?
17.5 minus 3,000 over x.
You betcha. And now we are going to expand the right side. And once that's all tickety-boo, we are going to bring the 3,000 over to the right to join the party. We are going to simplify this and then solve the quadratic equation. So 3,000 equals x times 17.5 is 17.5 x. X times minus 3,000 over x. Whoa, what do we do with that? Let's do a little sidebar here. If we're multiplying x, I'm going to ignore the negative for a second. 3,000 over x. What we're going to get, yeah, we're going to get 3,000x over x, but as Cole very rightly pointed out, you can divide out the x's or cancel them out and just end up with the number 3,000. So we're going to get minus 3,000. And then we are going to take 100 and multiply it by 17.5. So that's going to give us
17,050.
1,750. Yep. And then we are going to do one last product, which is 100 times minus 3,000 over x. And that's going to give us minus 300,000 over x. Now, probably the easiest thing to do. See, when I look at this, I don't like this because there's something over x. So in order to fix that problem, what we are going to do is we are going to multiply everything by x. Everything. So the first term on the left becomes 3,000x. The first term on the right becomes 17.5 x squared. There was an x. We multiply it by another x. So we get x squared. Then we get minus 3,000x plus 1750x. Using the same logic we used before, if we multiply 300,000 over x by x, we just get 300,000 full stop. And now we will bring the 3,000x over to the right side and simplify. So we're just making sure to put all of our like terms together. So we're going to get 17.5x squared. I did forget it on the line above. I just corrected it. Minus 4,250x minus 300,000. I really see a hope of we can divide to make this. I mean, we don't have to do any kind of simplifying, but if we simplify, it's going to make our lives easier. So I'm all about making our lives easier if we can. And we can make our lives easier by dividing all three terms by 2.5. If you divide everything by 2.5, you get 7x squared minus 1,700. Please correct me if I'm wrong.
I think it's 1,610.
It's what? Sorry?
1,600. It's 1,700.
Okay.
No, it's 1,610. Or negative 1,600.
No, I get 1,700.
1,700.
Yeah. 5.
By 2.5.
Divide 300,000 by 2.5. What do we get? Right? And now 300,000 divided by 2.5. I think it's 120,000. No worries. Okay. So now this is a lot easier to play with. Now,
Let's go.
when we get the quadratic equation to this step, we can go a whole bunch of different ways. We can, you don't have to write this down. I'm just going over this with you to show you. We can factor it. We can complete the square. Or we can use the quadratic
Yes, that's way better.
formula.
Way better.
Now, Cole used an interesting analogy yesterday in a very different context, but I'm going to just be honest with you. If you can factor a quadratic formula, it's always easier to factor it than to use the quadratic formula. But there are some quadratics that are unfactorable, and there are some quadratics that are a pain in the butt to factor. And you might forget how to factor sometimes. So the quadratic formula will always work for you. Completing the square will always work for you, but it's a little bit more aggravating than completing the quadratic formula. And factoring is wicked and it's awesome and it works if you can factor it. So the quadratic formula is beautiful, but it takes a lot of time. So you have to pick the best tool for the job. I think using the quadratic formula all the time is like using a sledgehammer to nail in a little nail into the wall. It might be unnecessary all the time if you're able to factor it. But it'll always work for you. So it's a nice tool. Now today's lesson is all about solving word problems using the quadratic formula. So even if I knew how to factor this, we're not going to factor this because I want to get us practice with using the quadratic formula. So that's what we're going to do. We are going to use the quadratic formula. So for the quadratic formula, A is 7,
This is such a long.
B is minus 1,700, C is minus 120,000. And that's what we're going to plug into the quadratic formula. So it's going to be 1,700, because that's minus B, plus or minus,
They came out when the iPhone X came out.
minus 1,700 squared, minus 4 times 7, times minus 120,000. All over 2 times 7. So let's work it out. 1,700 squared is 2,890,000 plus, I can't do that, 28 times 120,000 is 3,360,000 all over 14. So we're adding the numbers underneath the square root. We add them together and we get a really nice number. We get 6,250,000. Now it's a really nice number because it's a perfect square. When we take the square root of 6,250,000, it's exactly 2,500.
Always work for one question.
2,500. We get two solutions here. One of them is going to be rejected, in this case, because we get 1,700 plus 2,500 over 14, or 1,700 minus 2,500 over 14. So here's the deal. The second answer is negative. It's going to be rejected. When we talk about the speed of a plane, speed can't be negative. Now, technically, if you're in a physics class, you could tell me that velocity can be negative, and you're right. But speed cannot be negative. So that second answer is going to be negative, so we reject it. It's not going to be a good answer. But 4,200 can be divided by 14, and it's exactly 300 times. So the speed of the plane is 300 kilometers an hour. Let's tie this up with a nice bow by going ahead and putting a therefore statement. Therefore, the speed of the plane from Thunder Bay to Halifax is 300 kilometers an hour. Next question. This is a familiar one. Find the sum of the squares of three consecutive even numbers if they are 509. Like the sum of the squares of three consecutive even numbers is 596. Find the numbers. We've seen this kind of question before. So, we're going to start off by making our let statements. Let. Start off with the smallest number. Let's let n represent the smallest number. Now, there's a variation of this question. Sometimes it'll be three consecutive numbers. Sometimes it'll be three consecutive even numbers. Sometimes it'll be three consecutive odd numbers. This variation is three consecutive even numbers. How do you go from one even number to the next even number? You add 2. So let n plus 2 represent the middle number. And what would be the let statement for the largest number?
Let n plus 4 represent large number.
Beautiful. So those are the let statements. And this is, like I said, the two hardest things when you do these questions is come up with the let statements and then come up with the questions. I used to use an analogy when I tutored a lot in university. And I'd be helping high school kids doing these types of questions. Think of this like a magic show. The first time you go to the magic show and the magician shows you a trick, you're wowed by it. You have no idea how they're doing that really cool trick. But if you pay attention to what they're doing, that maybe not the second time, but the third or fourth time you see that trick, you're going to understand what they're doing to make sure that the illusion is there, and you're going to figure it out. So But a magician, like a magician only has a certain number of tricks. A magician's not going to put on a show and do 700 tricks. The magician's going to do 4 or 5 or maybe 6 tricks. And there's maybe 3, 4, 5 different types of problems I could throw at you. So if you do a variety of each, you're going to figure out the trick. And it's not going to be very tricky anymore. Okay? So now, reading the question, the sum of the squares. So it means we're going to be squaring these numbers and doing what with the squares? Adding them. Yep. So n squared plus n plus 2 squared plus n plus 4 squared equals 596. Then it's just a matter of expanding both of the binomials and collecting your like terms. N plus 2 squared is n squared plus 4n plus 4.
Wait, where'd you get the 4 from? Sorry, like there's a 4. It just magically appears?
Yes, it just magically appears. This is all just my magic trick to you. No. N plus 2 squared means n plus 2 times n plus 2. So when we work that out, it's n times n, which is n squared. Then it's n times 2, which is 2n.
Oh, so
Then-
you're factoring them with each other, you're factoring them by themselves.
Yes. 2 times n is 2n, and then 2 times 2 is 4. So putting it all together, it's n squared plus 4n plus 4. Now, what would n plus 4 squared be? It's n squared. Give me the rest. Yes. 8n plus 16. Exactly.
Like I said, they have in there. I do put a pencil in it, but I didn't realize like the things were responsive it, and I hid it or something, and I just like wax on my hands. Fix it. She's like, what the fuck? My feet.
So, it's like 3n squared plus 12n plus 20.
So we got 3n squared plus 12n plus 20. That's correct. And then we're going to bring the 596 over so it becomes negative. And then we're just going to put that together.
76.
So, quadratic formula. So it'd be n squared plus 4n minus 192? No.
Yeah.
Yeah, okay. Equals 0.
Wouldn't it be? Yeah. Are you taking the 11?
If we divide everything by 3. Now, if you know your factors of 192, you can factor this. I know what they are. But, actually, do I? Yes, I do. I know what it is. But, again, the quadratic formula is that nice little security blanket that will help you when you don't know how to factor or you don't want to factor. Okay?
Why are you looking at me when you say this?
Okay.
Would you rather factor this, Cole, or would you rather use the quadratic formula?
You know, I totally know how to factor, but let's just do it, like, because you seem to really like the quadratic formula.
Okay, let's use the quadratic formula. Now, this is n equals, not x equals, because n is our variable. N equals minus b, so that's minus 4, plus or minus the square root of 4 squared minus 4. A is 1 times c which is negative 192, all over
How do I tell which
2 times 1.
no, why don't I just pick a point?
You want
Like
fast?
here.
Negative 4 plus or minus 16 plus 768. Yes.
Yep.
Over 2.
Holy shit.
Oh, okay. I got it. Cool. And then
768 plus 16. 784. 784 special because it's a perfect square.
Negative 4 over 28 divided by 2, and you get
or no, what I'm on.
negative 4 plus minus.
And it is 28.
Yeah.
So we get negative 4 plus 28 over 2. And negative 4 minus 28 over 2. So we get 24 over 2 minus 32 over 2, which gives us 12, and minus 16. So, if our first number is 12, then our n plus 2 is 14. And our n plus 4 is 16. So that gives us the numbers 12, 14, and 16.
And we get negative 16, negative 14, and negative 12.
Bingo. If we start at negative 16, we get negative 14, and then we get negative 12, which gives us the two sets of numbers 12, 14, 16, and negative 16, negative 14, negative 12. So in this case, both sets of numbers are the solution. Not one set of numbers, both set of numbers.
But,
So we'll therefore, the 3 consecutive even numbers with a sum of squares of 596 are 12, 14, 16, and minus 16, minus 14, minus 12. The next, Mr. Johnston wants to order some basketballs and volleyballs. He orders a total of 30 basketballs, volleyballs. So not 30 basketballs, 30 volleyballs, but if you add the number of each together, you get 30. Volleyballs cost $3 less than basketballs. The volleyballs cost $340. The basketballs cost $200. How many of each did he purchase? So this is like the fly-in question. It's a chart question. So in this question, we have basketballs and volleyballs. And we have total cost. We have unit cost. So that's the price per basketball or the price per volleyball. And we have the number purchased. So as just a simple example, if a volleyball was $25 and you ordered 18 of them, you would multiply the number you buy by the cost of each one, and that would give you your total cost. So the total amount spent is going to equal the unit cost times the number of them that you purchase. Now, because we are in the interest of time, what I'll actually do is I'm going to get you guys through the chart. We'll set up the equation.
So I'm not trying to find the
And then maybe I'll teach the grade 10 lesson and see if you guys can answer the question while I teach them. Well, we'll see how far it is along. We'll see how it goes here. All right. So we know that the volleyballs cost $340. We know the basketballs cost $200. Okay? So we could put those numbers in for the cost of each type. Okay? We want to find out how many of each did he purchase. So we want to find out this and this. That's what we want to find out. And he orders a total of 30 of them. So I'm going to use N for the number of basketballs. Can you give me an algebraic expression for the number of volleyballs?
N minus 3.
30 minus N. Because however many basketballs he purchased 30 minus N volleyballs.
And then divide 8 by 2.
Now, for the unit cost, volleyballs cost $3 less than basketballs. So, to find the unit cost, you're going to divide the total amount of money by the number that you buy. So the unit price for basketballs is 200 divided by N.
Yeah.
It's just the total cost divided by the number that you buy. And volleyballs cost $3 less. So really, the volleyball cost is going to be 200 over N. $3 less though, so minus 3. And this right here is what we're going to use to build our quadratic equation. 340 equals 200 over N minus 3 times 30 minus N.
Are we gonna times 200 over N minus 3 by N?
Yeah, we will. We're going to multiply. First, we're going to multiply it by 30. Then we're going to multiply it by N. And then we're going to multiply 3 by 30. And then the 3 by the N. Because it's like FOIL, right? So it's going to be 340 equals 6,000 over N minus, when we multiply 200 over N by N, it's just going to be 200. And then it's minus 3 times 30, which is minus 90. And then plus 3N. And then we're going to multiply everything by N. So that's 340N equals 6,000 minus 200N minus 90N plus 3N squared.
Now we want to bring over that before?
You betcha. So we have 3N squared minus 290N minus 340N plus 6,000.
So 3N squared plus 639 minus 600.
630N. Right?
Minus
Yeah.
minus
plus 6,000. Everything here is divisible by 3. So it's n squared minus 210n plus 2,000. Do I like that? I think I do. Yes, we do. I do. Yeah, I got it. Okay. Again, if you could factor this, you'd be off to the races. If you can't factor it, that's okay. If you don't want to factor it, that's okay. That's what the quadratic formula is for. So n is going to equal minus b, so that's 210 plus or minus square root of minus 210 squared minus 4 times 1 times 2,000 over 2 times 1. So that's 44,100 minus 8,000. Yes. All over 2. So if you subtract the numbers in the roots, you get 36,100 all over 2. Square root of 36,100 is 190. So we get 210. So we got 400 over 2 or 20 over 2. So we either get 200 or 10. Now, one of those answers is really good and one of them is really bad. Which one can we say, get out of there?
Negative. No, 10. 200.
200. Because there's only 30 combined volleyballs and basketballs bought together.
There's 10 volleyballs.
So we can get the 200 out of there, and that leaves us with 10. In our table, n represents the number of basketballs. So we would write, therefore, Mr. Johnston buys 10 basketballs and 20 volleyballs.